We're going to take a look at identifying trig ratios. So this is the beginning of our new trig unit. So kind of lesson 1A, just kind of getting some of the basics down. So a little bit of vocab and a little bit of understanding what's going on with these different ratios. Basically, when we're dealing with trig, it's basically the study of those right triangles. We're going to be dealing with a lot of angles in those right triangles. But we're also going to be focused on how they relate to the sides of a right triangle. Now, in order to determine like which sides we're interested in, we're going to be naming these sides a few different things. The one you're so familiar with is the hypotenuse. The hypotenuse is the longest side of that right triangle. So the hypotenuse of a right triangle is opposite that right angle. This is our hypotenuse. In shorthand, we'll often just use like the letter H to label that. You'll also see something referred to as the opposite side. The opposite side is always going to be opposite the angle that we're looking at. So if you guys look at this symbol right down here, this little like circle with a line through it, we call that the angle theta with like a TH. So theta is usually the variable we use for angles. Sometimes we'll use the names of the triangles, sometimes we'll use x, but theta is a very common term for that angle, right, variable that we use for the angle. So the opposite side is always going to be across from angle theta, right, directly through the triangle across to the opposite side. Again, we'll usually use an O to represent that. And then we're also going to take a look at the adjacent side. The adjacent side is the side basically kind of like the third leftover side, but it's the one next to the angle. That's not the hypotenuse. So this is our adjacent side. And a lot of times you'll see me label this with just simply an A. So as we're kind of like working through this, we got to understand that opposite and adjacent are just going to, it depends where the angle is, right? What opposite is going to be. For instance, we have these two triangles, two examples down below. We're trying to identify what the different sides are. Which side is the hypotenuse? Well, we know the hypotenuse is opposite that right angle, so it's going to be AC, right? This is going to be our hypotenuse. Which leg is opposite theta? We look across that triangle, so it's got to be BC for our opposite side. And then our adjacent is that missing leftover side. That's going to be side AB as we look at those three sides. All right, so if you guys could pause real quick, try this next one. For the next one, the opposite, again, is across from that right angle. So it's PN. The opposite of theta is across from theta, so MN. And the leg adjacent is going to be PM. So just kind of getting used to and identifying those sides. Now, we have these things called trigonometric ratios. Now, these trig ratios are basically what help us find some type of like similar triangle relationship between all different right triangles. So one thing that's important in this is we use this like little word to help us remember those trig ratios called SOHCAHTOA. Basically, the sine of the theta is equal to the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. And then the tangent is the opposite side over the adjacent side. Now, the way SOHCAHTOA kind of helps, I usually like to rewrite it in a different way. Like I'll say S is the O over H. So that's just telling me sine is opposite over hypotenuse. The cosine, A over H, so the adjacent over the hypotenuse, and the tangent, the opposite over the adjacent. So just kind of giving us that SOHCAHTOA trig ratio. Now, just today we're going to get some practice in identifying those different ratios. So how do we use these ratios? Well, first thing I like to do is when I see my theta, I'm going to label what's my opposite, what's my hypotenuse, what's my adjacent. So I know my opposite is going to be the 3 over here. My hypotenuse is the 5, and the adjacent is the 4. So if I'm trying to find the sine of angle theta, that's the opposite, or 3 over the hypotenuse, 5. The cosine is the adjacent, 4 over the hypotenuse, 5. And finally, the tangent is the opposite 3 over the adjacent 4. And so those different ratios really just come from understanding the names of the different sides and how to relate them with SOHCAHTOA. Now, one thing that we sometimes run into with our missing sides is and needing to use the Pythagorean is we sometimes need to use the Pythagorean theorem to find that missing side. So for instance, in this triangle here, we don't have the hypotenuse. So in order for me to find sine, I need that hypotenuse. So I'm just going to throw that into the Pythagorean theorem since I'm missing that one angle. We're going to have 6 squared plus 7 squared, which we have is 85, equals c squared. And I'll take the square root of that. Now, 85 is not a perfect square root, so we're just going to leave this guy here as radical 85. We could try and simplify it, but it's 5 and 17, which are both prime numbers, so we'll leave it as rad 85. So the sine, the opposite, 6 over radical 85. Now, sometimes you might need to rationalize that denominator, but I'm just going to leave them as our fractions for today. The adjacent would be 7 over the square root of 85, and the tangent, the opposite over adjacent, is 6 over 7. For the next example, you guys could hit pause if you want, or just kind of follow along. All right, we got to find that hypotenuse. So we're going to say 8 squared plus 12 squared is equal to c squared. When we do our 8 squared plus 12 squared, we have 64 plus 144, which we end up with 208. So c squared is equal to 208. And again, we could try and work on simplifying this one. 208 does simplify a little bit. So if we want to break down that radical, we can. We don't necessarily need to since it's not a perfect square root, but square root of 208, if we were to break this thing down, I'm going to divide it by 2. When we divide it by 2, we get 2 and 104. The 104 I'll break down to 2 and 52, then 2 and 26, right? A lot of 2's we could break this thing down to 2 and 13. And finally, we have our prime numbers. So this thing can reduce to 4 radical 13 if we wanted to. For our purposes though today, I'm just going to leave them as the square root of 208. So the sine of theta is the opposite, 12 over the square root of 208. The cosine is the adjacent 8 over the square root of 208 for our hypotenuse. And then finally, the tangent is 12 over 8, right? Our opposite over adjacent. There's some practice online on delta for you guys, so give that a shot and let me know how everything's going.